All right. Hello, everyone. Can you hear? We good? All right. Can we hear? All right. Now we have to do it. Audio check. Audio check. Are we good? Are we good? Audio check. All right. We're not done. We got the light. We are now on. Hey, only a 1 minute delay. Okay. Video, video, video. Video. Whoop. Whee. Hello, everyone. We are on. Look at that. Only a 1 minute delay for all those technical difficulties. Hello, everyone. I'm Ming Chow. I'm Associate Teaching Professor at Tufts. This is now episode 2, season 9, and today is a topic I do quite a bit. I actually give this training quite a bit, each and every so often, like every 2 months. Uh, Smile. You're gonna like today. It's also gonna be kind of dense. And today, of course, is going to be hands-on. So today we're going to do what is called packet analysis or network traffic analysis using Wireshark. So I'm actually kind of surprised that for the last couple of days I've been wearing a shirt. I don't know if you can see the badge. Can you see the badge? A lot of you folks are like, didn't ask, like, what's the wall of sheep? What is the wall of sheep? Yes, that's my other email address. Ming at wallofsheep.com. Yeah, that's my email address. So, whoa, wait a minute. What in the world is that? Well, it has everything to do with this um, stream presentation training today. So, I want to give you a little bit of a motivation. So, have anyone ever heard of DEF CON? The security conference that parents tell their kids not to go to because everything breaks, everything will get hacked. List goes on. Uh, it is an infamous cybersecurity conference that I work at. Hey, Oblivion, there we are. Hey, you can hear, right? We're good? Because it looks like the stream manager on my Twitch app is kind of broken, but that's okay. So, for those of you who are serious in doing cybersecurity in the future and as a profession, you got to go to DEF CON at least one time in your lifetime. My first DEF CON was in 2006. DEF CON is held each and every summer in beautiful Las Vegas, Nevada, around July, August in the summer. Um, it is now a conference where you don't have only hobbyists, security researchers, practitioners, professionals, um, criminals, hackers, lawyers. We even have the White House going, the federal government, law enforcement, lawyers. List goes on. And one of the most sobering sights at DEF CON each and every year is what is called the wall of sheep. When people go to DEF CON for the first time, many people say, I gotta take a picture of the wall of sheep. They gotta take a picture of the wall of sheep. I wanna see what's on the wall of sheep. I wanna get on the wall of sheep. List goes on. What is the wall of sheep? I remember my first time going to DEF CON in 2006. I was like deer in the headlights. And I also saw the wall of sheep. And I was like, what the hell is going on? Well, the wall of sheep team has access to arguably the world's most dangerous computer network. Because as I said earlier, all those people, good, bad, and you don't even know, federal government, they all share and use the same network. And the Wall of Sheep team monitors the entire conference network. And what the Wall of Sheep team does is they monitor the DEF CON network and they will find and pull any sensitive information, especially usernames and passwords, sent insecurely on the DEF CON network and post it on this wall. And the wall will have a list of username, password with the first three letters of the password not censored, the rest of the password censored, because we don't want other people to be breaking to be reusing credentials that we found or that are sent insecurely. The domain or the IP and the application which we found and used the application on. Hey, Bot Ranger 24. And this wall of sheep for years has been pretty sobering. I remember back in 2009 when I was working on the Wall of Sheep team, we found like Twitter, Gmail, Facebook credentials. It was everything galore. It was like credentials galore. Fun times. We saw everything, the activities that people were doing, the pictures that people were sending back and forth. List goes on. In 2010, we even did a fundraiser for the Electronic Frontier Foundation, the EFF, called a Peekaboo Booth, and showing people all the pictures, usually not, not safe for work pictures that people were looking at and browsing at on the DEF CON network. You may think that this is a wall of shame, and it is not. We don't look at it that way. The thing is, the wall of sheep really is an educational opportunity. So I want to talk to you a little bit about the Wall of Sheep team, which has now evolved into running the Packet Hacking Village at DEF CON. So about us. So our mission at the Wall of Sheep and the Packet Hacking Village is security awareness and training. Is to make people aware. This is what happens when you send credentials and sensitive information on untrusted computer networks and when you send information in plain text. We accomplish our mission by way of interactive demonstration and unconventional method. Our team is all volunteers. We all pay for our way out to Vegas each and every summer. And for me, each and every year, it becomes one of the best money that money can spend because I work with the team for years, over a decade now. And it's gotten to a point, yeah, this organization, this group is basically everyone we've known each other for all these years. It's as good as family. Yes, I can say that. I mean, the same cannot be said about, about almost all workplaces. But this team has been around together for us. I mean, this is like an only time seeing each other, and want to give a shout out to the Wall of Sheep team. You know who you are. And I also want to add, and I want to say this on the air publicly, if I haven't said this before. When I got my master's degree in computer science, I had no idea that cybersecurity was even a thing for me. I swear. And the Wall of Sheep team, and I've always credited them, of giving me the education in cybersecurity and the basics, such as understanding networks and networks. They've given me all those, and I've learned from them. They gave me the education that I needed. All these stuff was not learned in school. And so now, in return, I give this education to everyone, including everyone that's listening here. That's everyone that's with us. So what is packet analysis? Packet analysis is look at it and understanding computer network traffic. Packet analysis goes by a whole bunch of names, also known as analyzing packets, also known as network traffic analysis, also known as packet sniffing, aka protocol analysis, aka packet tracing, all the same name. Why? Now, one thing is I haven't said before is that packet analysis, like any cybersecurity tool and technique, can be used for both good and bad. I repeat, everything that you learn can be used for good and bad, good or bad, double-edged sword. Packet analysis has been used for years for troubleshooting networking issues, recording communications, that include email, voice, and chat. Yes, we will actually reconstruct pictures and video and media sent insecurely on a network, reconstruct analyzing web traffic, and of course to catch usernames and password, personal information, and other sensitive information that was sent insecurely in plain text. You can all hear and see, right, the stream, because it seems like the Twitch app is broken. Chime in, please. Now, this, I want to give you another bit of motivation. This is wording from Wired magazine. Okay, hey anonymous worshipping. You can hear and see, right? I'm a little worried because the the Twitch app is like broken as hell. So, fall 2017, 7 years, almost 7 years ago. I had a student. Um, I'm not going to say who it is. Um, she was fantastic. Actually, I can. Rebecca Albert. I'm going to give you a shout out. Thanks, Rebecca. She and I almost started World War III on Twitter. And it was because there was this article written by Wired magazine. And she showed me the article, and it was like, hey, man, you got to look at this. This is like, the article is so, like, wonky. And the article was, quote, on the compromised devices. The article was about the Mirai botnet. They carefully had to reconstruct the network traffic data and study how the Mirai code launched so-called packets against its targets. A little understood forensics process known as analyzing packet capture data. Think of it as the digital equivalent of testing fingerprints or gunshot residue. It was the most complex DDoS software I've ever run. I've run across, Klein said. And I read this. I was like, my mind was ready. I can't understand a damn thing. This could be better written. And we contacted the writer on Twitter. It's like, yeah, this is how you can write this paragraph a lot better. So today, the whole gist of today is to teach you about, for me to, talk about you know, and give you a tutorial on packets and quote unquote this little understood forensics process better known as analyzing PCAP, or packet capture data. I want to give a shout out to Garrett Graff, who wrote this. He's a good sport, good guy. Okay. There's also another running joke in the cybersecurity field called PCAP or it didn't happen, or packets or it didn't happen. So what is a packet? Hey, we're on Twitch right now. Hey. A packet is just, in very short, a unit of data. A data stream, such as, this Twitch stream right now. Anytime you download a web page, anytime you go, if you go on the internet, anything that you do on the internet, like this Twitch stream is comprised of many packets. Many packets. So right now, if you are trying to analyze this Twitch stream, you're going to see many packets. So in general, a single network packet contains the following information: source and destination address, MAC address, time to live, the protocol that is being used. Now, I was very careful, source and destination IP address. That's typically the source and destination IP address, but for even things like Bluetooth, they have source and destination address, but not necessarily IP. Hardware address, gotta have that. And a single packet encapsulates all the layers of what is called the Open Systems Interconnection Model, which I've said for a very long time, and I know a lot of network professionals appreciate me for saying that. It's a theoretical model on how quote unquote a networking or telecommunication system should function. This is one of my most hated topics to talk about, because the OSI model, a lot of it doesn't make any sense and is confusing as hell. The OSI model, all you need to know is 7 layers. Each layer is abstracted from each other, and you also have to, of course, it goes from the highest level of abstraction to the lowest level of abstraction, things that you don't care about. The highest level of abstraction are things that you do use and love every day, such as web, email, file management, video games, list goes on. But seriously, the OSI model, all you need to know are 7 layers, okay? Each layer abstracted away from each other. Each layer don't have an idea what the hell the other layer is doing. But each layer has a responsibility. The application layer is, the end user layer, which makes things easy for people to use. That's layer 7. Layer 6 is presentation. Layer 5 is session. We don't necessarily care or talk about 6 and 5. 4 and 3, layers 4 and 3, transport layer and network layer, we do look at quite a bit. Think of the network layer, layer 3, as just the source and destination IP address, while the transport layer, TCP, are used for things like host control, flow control, has pieces of your email data, web page data, you name it. Data link layer, think of it as hardware address, MAC address. And the physical structure is a physical layer at the very lowest level of abstraction. Layer 1, cables, hubs, repeaters, list goes on. Like things like the air, silicon. And here's another illustration of the OSI model. And you can see it goes from the highest level of abstraction to the lowest level of abstraction, layer 7 to 1. Okay? Uh, the session layer is for inter-host communication, for session establishment. Transport layer is for end-to-end connectivity and reliability. One of the things I talk a lot about, and we look at, is the TCP three-way handshake, and that the TCP three-way handshake, TCP with transfer transmission control protocol, is to ensure a reliable connection between two computers. Reliable connection. Sync ACK, and ACK. Network layer is just IP for logical addressing. Physical addressing, the data link is MAC address of your hardware. Media signals and binaries flows level. One thing is that with the OSI model, a good analogy of the real world, which people use all the time, is the postal service. All you care about when you try to mail a letter is you just put your stamp, addressed envelope, and your package or mail in the mailbox, and hopefully it gets to your destination within 3 days. The source and destination address on a mail is to think of it as on the network layer. But generally speaking, that's all you care about. You don't care about the blue bin or the mail sorting facility or the mail trucks or the airplane. You don't care about that. But everything under the hood, there's a lot going on. I loved this picture with the OSI model in action. This is a message of sending one Reddit user to another Reddit user. The OSI model is super hard to explain, but this one I feel, you know, everyone uses on Reddit, and it kind of makes sense. When you're trying to send a message from one Reddit user to another user, it just goes from the highest level of abstraction to the lowest level of abstraction, then all the way up back to the user. If the layers of an interconnect are clueless about each other, how do they stack together and act as an interconnect? That's a great question by Karamba. They actually have to work together. And we're going to see an example, a really good example. They are clueless about each other. They stack together and they actually they have to stack together. Have you ever heard of the term called TCP/IP? You may see this on Windows. You may see TCP/IP used on systems, like on system settings on Windows, on a Mac. Here's the thing. There's a reason why it's always called TCP/IP. You almost never hear TCP or IP separately. They go together. Okay, is it you can't do TCP/IP one or the other. It's usually one. They both have to be together. And I'll show you that when we actually get to look at network traffic together. Is it safe to think of the transport layer as a layer that operates within the source and destination, kind of like the last mile network? Uh, is it safe to think of the transport layer as a layer that operates within the source and destination network? As sort of like the last mile. Well, certainly it is important. I wouldn't say it is the last mile, but but close enough. The frog's question is good. Almost as a last mile layer. In fact, we're going to see one in a few moments. Hang on. So this is a Reddit picture of one Reddit user sending a message to another Reddit user, but it goes from the application layer to application, like message goes to the application layer, then the application layer talks to the transport layer talks to the internet layer to the link layer talks to the physical layer. Now it goes work up the chain, physical layer go back to the link layer to internet layer to transport layer to application layer. Told you no one cares about layers 5 and 6. And then of course the application layer goes to the recipient Reddit user, you fool. Alright, so what is a PCAP file? A PCAP file is just a file, but PCAP stands for packet capture. So a .pcap file .pcap is the file extension. And it's commonly used in applications like Wireshark, which will come next. So a PCAP file is just going to contain many network packets. Give you an example, a 100 megabyte PCAP file usually can contain tens of thousands of packets. And so now, folks, maybe it's time to have some fun. So wait a minute. I mentioned earlier about, and I've been mentioning this for, on occasion, as Wireshark. So what is Wireshark? Wireshark is a graphical and extensive packet analyzer. If you're doing anything computer networking related, Wireshark is arguably the number one, almost by far and away, the most important tool to use. If you're doing cybersecurity, anything cybersecurity, Wireshark is like one of the most important tools, usually like top 3. Wireshark is open source, it's platform independent, it's free, it includes features such as filtering, reconstructing conversation, reconstructing files based on packet. We don't have, just open up, not Wireshark, I'm gonna open up my browser. Yes. Go to wireshark.org. Wireshark.org. Love these guys. Can I do that? Oop. I can copy. And I should be able to paste this and send it to everyone. Chat. Yes. There it is. Gonna download. Download Wireshark for your respective platform. Is it illegal to capture packets in a public network? Luffy, you asked an age-old question, and this is a very good question. The answer is it illegal to capture packets in a public network? And the answer is, well, everyone does it all the time. Everyone does it all the time. Yep, that's a mechanical keyboard. But going back, oh no, people do this all the time. I mean, God forbid if you're like at an airport or at a Starbucks. I mean, people record network traffic all the time. Is it illegal? No. Is it sketchy at times? You be the judge. You be the judge. And again, capturing packets, it can be used for both good and bad. Of course, hey, if you go to Vegas for DEF CON and you're at the Starbucks and you see someone with a long antenna sticking out of the laptop, oh yeah, I mean, you're probably, that person's up to no good. But you can't judge, because what happened if the person that is recording network traffic on at the Starbucks network is actually trying to troubleshoot the network? You just don't know. So that's why, is it illegal to capture packets on a public network? The answer is no. People do it all the time. Is it sketchy? Well, you be the judge. If you're an airport network, I mean, those things get overtaken all the time. So that's a great question. So no, I mean, people do it all the time for public networks. I mean, there were times that I had to even do it for a project, a legitimate project. Okay? So Wireshark is free and open source, and we're going to use it. This is a little bit of the interface. It has changed a little bit. But really, the Wireshark user interface, for anyone who's new, it may seem like really overwhelming. And and I can understand. I mean, I had trouble using Wireshark initially, but really is the four main components of a Wireshark interface. First, the toolbar. That's where you can do search, filtering, capturing packets, opening files, you name it. The second and third panes are the ones that we're going to use the most. Then there is a table of all the packets. It's a packet list. That's right below, well now, right below that, now the packet details and packet byte panes are to the left and to the right of each other. They're no longer stacked on top of each other. The packet details pane is where you can click on a packet and you can actually see all the layers of the packet. And the last pane is the packet bytes, the packet in binary. Okay? When you capture packets, are you necessarily preventing them from reaching their destination, or do you record a copy? Record a copy. Record a copy. Absolutely, like taking a photo. Yep, absolutely. That's what SoCal Neela said. Yeah, so it's copying, okay? Not preventing. That's a totally different world of hell, okay? So what we're going to do is we're going to do 4 exercises for today. Real exercises. So you go to github.com/mchow/bootcamp. And so all the files that we're going to use, I just want to give you a warning right now. There is also actually real malware here. So if you actually, there's actually real malware, because I actually do a training on malware analysis as well too. And if you clone, so if you clone the entire repository, you're going to get a warning saying malware detected. That's correct. So, but if you don't want to clone the entire repository, that's fine, because I'm just going to post a link to the PCAP files that we're going to analyze today. And there are 1, 2, 3, 4 PCAP files we are going to look at today. The first one is going to be set1.pcap. Set1.pcap, but as you know, oh, wait a minute, set1.pcap, don't be fooled. You can download, up. You can download this, go to raw, yep, there it is. You can hit save, there you go. Copy link. And this is going to be set1.pcap. I'm going to post a link on Twitch so you can play along. Yeah. There we go. Oh, that works. That switching works. 715 bytes. 715 bytes. Not a lot. Should be a really small file, right? Yeah. So I'm going to open up my terminal now. Now, just to show there's no magic tricks, there are 2 files on my desktop. Doing LS. There is this presentation, which I will give to each and every, like for those of you who are interested, who wants it. It's going to be made available after today. And then set1.pcap. Now, remember last session, we did Unix commands. And today, you're going to see Unix commands again. We're going to use Linux Unix command. We're going to use them again. By doing ls-l, as you can see, set1.pcap is 715 bytes. Now, can I open up the PCAP? Can I look at the PCAP file on a terminal? You sure you can. Sure you can. Set1.pcap, you can see, right? I'm just going to concatenate the entire set1.pcap file, it's only 715 bytes, out to the terminal, and voila. See the problem? First of all, there's a lot of garbage characters. Lots and lots of garbage characters and hardly any human readable text. This, my friends, is what happened when you take a look at a PCAP file using a command line terminal. I'm not going to get a whole hell of a lot out of here. 715 bytes, yeah, just 715 bytes of data. All garbage. You can even hear the beep, beep, beep. Clear the screen. Now you know what it's like, what a PCAP file really is. It's binary. Oh, one thing I should also do. What if I do a file set1.pcap, and the file command says this is a PCAP capture file. Okay. Now, what happens if we open this up in Wireshark? Take a look at the difference. We're going to open up set1.pcap in Wireshark, just double click on the file, and there you go, my friends. There you go. Here, my friends, is set1.pcap. Now I can enlarge. Notice what happens when you click on each and every row in the table. The packet details pane now is on the bottom left, gets changed, and also you can also see the binary data also change. Packet 1, packet 2, packet 3, packet 4, packet 5, packet 6, packet 7, packet 8. And that, my friends, is my introduction. Welcome to Wireshark. All right, so now let's do a few exercises. Let's do a few exercises, shall we? There we go. Exercise number 1, opening up a simple PCAP file. So we open up set number 1.pcap in Wireshark. Question number 1, how many packets are there? Question number 2, what networking protocol is used? Question number 3 is, what is the source IP address? Question number 4 is, what's the destination IP address? Question number 5 is, what port is used as a source using to communicate with the destination? What is the port number what port number is a destination listening on? Bonus, do you notice a TCP three-way handshake? So I think we can commit these questions to memory. Okay, the number of packets, the networking protocol that's used, the source and destination IP, port numbers. Take a look at Wireshark. Here we go. Well, to actually see the number, to count the number of packets, the link is deleted here, different than the link you sent. I got this from yeah, I mean, if it's on GitHub, it's the same file. I mean, we're using the one on GitHub primarily. Yeah, we use the one on GitHub. If it's from GitHub on the mchow01 bootcamp repository, it's the same. That's what we're using. So for the number of packets, there's 1. Just count the number of rows in the table. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's only 8 packets. Yeah, this is like, we looked earlier at set1.pcap on a terminal and could barely make anything of it. Now you're on Wireshark and opening up set1.pcap, you can see a lot more information. So yeah, the number of packets in this PCAP file, just count the number of rows, or scroll down to the very end and you'll see the final number. In this case, it's only 8 packets. Should be nice and simple. 8 packets in this PCAP file. Now, the next question gets a little tricky. The source and destination IP. Well, that gets interesting. Well, the good news is there are only 2 IP addresses in set1.pcap. 192.168.1.3 and 192.168.1.8. There's only 2 IP addresses, but which one's the source and which one's the destination? Okay. Yeah, I think you looked at the wrong PCAP file. We're not doing the homework. I'm not doing the homework for you folks. I'm not doing the homework for you folks. That's for you to figure out. But by the end of today, you will be able to do the homework with flying colors. So, okay, the good news is there's 2 IP addresses. The bad news is you can't assume that 192.168.1.3 is the source and 192.168.1.8 is the destination. Can't do that. However, what you need to do is take a look at the info column. The info column gives you a snapshot of what the packet contains. So it looks a little convoluted, but how you read this is the info column for one packet is that 49859 is a source port number and the destination port number is 7777. So how you read this is 192.168.1.3 at port 49859 is talking to 192.168.1.8 at port 7777. So these two numbers separated by a right arrow, yeah, a right arrow, because I'm on a right arrow, is port numbers. For packet number 2, that is 192.168.1.8 at port 7777 is talking, gave something to 192.168.1.3 at port 49859. Third packet is 192.168.1.3 at port 49859, gave something to 192.168.1.8 at port 7777. But you folks notice something very interesting here? The protocol that is used in each and every packet is TCP. We can see it by the protocol column. So each and every packet here is a TCP packet. And remember the OSI model in terms of the stacking? Well, if you click on a packet, any packet, you can get more information on the layers. In fact, let's click on the fourth packet. The fourth packet is now highlighted in blue, but you can see layer 2, Ethernet 2. You can see the destination MAC address and the source MAC address. You can see also that Wireshark does some pretty cool stuff, such as deducing the hardware type of the source and destination. In this case, the destination hardware MAC address is a Raspberry Pi, and the source is an Apple device. And I can confirm that this is true. So this PCAP file was talking from my Mac to a Raspberry Pi on my home network. Layer 2, Ethernet 2. Layer 3, the Internet protocol, the network protocol, IPv4, which Internet protocol is part of the network layer. And so the IP header, or the IP layer, only should have source and destination address and a few other things like time to live. Here it is, protocol, look at TCP, source address, destination address. So of course, even if you mouse over, like if you hover over a field like the source address, it will show you in the binary, in the raw binary, where the IP address 192.168.1.3 is. C0, A8, 01, 03 on the very right. This is the binary. And that's the destination. And of course, layer 4, the transmission control protocol, TCP, where you're going to find only source port, destination port. Yep, source port, destination port 1E61, and hex is 7777. And you can see other fields such as acknowledgement numbers, the TCP flags, such as sync, ACK, PSH, FIN. And of course, you can even see data sometimes too. Data include like text. Ooh. Does anyone notice something? Can we assume that source and destination by the top handshake? Well, yes, Luffy. Notice something very important. You see the TCP three-way handshake? You can see sync, ACK, and ACK, first 3 packets. A TCP three-way handshake happened. Sync, ACK, and ACK. There you go. TCP three-way handshake happened. And so you can now deduce that the source is really 192.160. Okay, so now how you read the first packet is 192.168.1.3 at port 49859 sent a sync packet to 192.168.1.8 at port 7777. So we now answered our questions, the protocol, the actual source, the actual destination, and the port number that the destination was listening on. So the source is 192.168.1.3, which is my Mac, and the destination is 192.168.1.8. The destination port number that I am talking to is port 7777. Why? what's the significance of port 7777? As you will see throughout this course, port number 7777 is typically used for no good. I repeat, port 7777 is typically used for no good or nefarious purposes. And each and every packet is just a simple TCP packet. That's it. So now, my friends, we did it all. We answered all these questions. The number of packet, the networking protocol used, just look at the column and the table, source and destination IP. Yeah, you're going to need to know the TCP three-way handshake to really figure out which is the source and which is the destination and the port number. Luffy, great question. Now, what happened if you want to reconstruct a conversation? Hey, like in the previous, in the set1.pcap, can we see what 192.168.1.3 sent to 192.168.1.8 at port 7777? And the answer is yes. Why is 7777 typically used for nefarious purposes? Historical reason. Back in the ye good old days, like in the 90s, the 2000s, a lot of malware used port 7777. When is the MAC address communicated between the two devices during the handshake? MAC address, believe it or not, MAC addresses is part of a packet, like during the handshake. Oh yeah, I mean, here's the thing: in a typical computer network packet, if you notice something very interesting about each and every packet here in set1.pcap, each and every packet, notice here in the packet detail, Ethernet, IP, and transmission control protocol. When you're using a typical computer network like the internet, your packet must contain IP address and the MAC address. They go together. So again, anytime you send a computer network packet, it's going to have to contain both the MAC address, source and destination, and the source and destination IP address. They go together. Remember, I think whoever asked that question, like, does the layers stack on top of each other? Oh yeah. Like a single network packet will have MAC address, IP address, and of course more protocol information like TCP. To reconstruct the conversation of Wireshark, all you need to do really is to click on a packet, any packet, so it'll be highlighted in blue, right click on the packet, and then you go to the follow option and follow one of the following streams. Usually TCP stream is the most common, but if you're using like HTTP, which is a thing, it will show up. That's a more specific application protocol. So I'm going to click the fifth packet here. I'm going to right click on it. I'm going to go all the way down to follow, and there's only one option, TCP stream. And now watch what happens. Can you see the MAC address once the packet passes the network layer, like after it passes the router? I usually is only the router IP, the router MAC address only. Oh shit. Here it is, but all the data is in raw. Well, let me do that again. Close this. Right click on a packet, follow TCP stream, and here it is. The entire conversation is 15 bytes. Between 192.168.1.3 of port 49859 to 192.168.1.8 at port 7777. But right now, all the data here is shown as raw. What happened when we show this as ASCII text? Raw is binary, so this is all like raw, think of it as binary. But what happened when we use ASCII text? Things that we can see. What, me worry? Yeah. So, 192.168.1.3 sent to 192.168.1.8, the message, what? Me worry. That's it. You can choose to save this to your file. You can even save this to your desktop or to anywhere on your system by the Save As button. Now, if the source is sending to the destination more than one file, such as a picture or whatever, you will be able to actually view the contents of the file or see that file by way of clicking up on Stream. Stream will start at index 0. Because there's no additional file that was or content that was sent from 192.168.1.3 to port 192.168.1.8 to port 7777, there's no additional stream. It's just, you can't click no. However, we're going to do that next. And so this is set 1.pcap. And so now to reconstruct the conversation, before we do that, the next exercise is we'll talk about reconstructing pictures sent insecurely using the file transfer protocol, which is insecure. Everything's sent in plain text. HTTP, the hypertext transfer protocol, is also sent. Everything is sent in plain text. Now, if you ever want to know what's the difference between unencrypted traffic, like unencrypted web traffic with HTTP, versus encrypted web traffic using HTTPS, versus using a virtual private network, a VPN, which just encrypts everything that you do on a network, even no matter how dangerous the network is, we're going to do that right now. I want to give you an example. There was a website called Tufts.io that supported both HTTP and HTTPS for years. Unfortunately, Tufts.io was something I did not run and it no longer exists. So there are 1, 2, 3. So what I did was I captured the traffic of Tufts.io when it uses HTTP, when it uses HTTPS, and when I'm on a VPN. And now I'm going to show you the difference. In fact, I do have the data here. Here it is. Tufts.io-insecure.pcap. I'm going to copy the raw copy link. I'm going to look at that first. Okay. So here's what happens. If you try to look at a PCAP file of an HTTP website, in this case, Tufts.io, I'm going to go to bootcamp, Tufts insecure, 233 bytes. Watch what happens. Boom. How many packets are here? 347. There's no filters here. But here's the thing. Anytime you see green, one of the things about coloring, like label, green in Wireshark by default means HTTP, insecure. Watch what happens. I can right-click the packet, follow TCP stream, and you can see all the HTTP headers, the footers, all the stuff. CSS content. Oh yeah, you can reconstruct a website that was sent in HTTP and Wireshark very easily. And maybe this is an icon here, I don't know, but what you can also do is, I'm going to clear the filter out. For cheating purposes, you can also do a file export objects, and you can even save all the HTTP content. You can do a save all, save it to your desktop, and it will dump the main.css file, jQuery.min.css file, a whole bunch of other things here. Favorite icon, it will dump all that. I'm not going to do that. Now, what happens if you try to open up the secure version? The HTTPS version of Tufts.io. How does that look in Wireshark? Yep, not printing. Open. Tufts Secure. Yeah, you still see the TCP three-way handshake, but then everything gets encrypted. Oh, I should actually show you in Tufts Insecure. Yeah, you can see the TCP three-way handshake happening between my computer and Tufts.io. The first thing that happens. But then it just does the HTTP request. Tough Secure, it does TCP three-way handshake, but then it does the encryption. This stuff right here has nothing to do with Tufts.io. It has to do with Firefox. Okay, so if I try to right-click follow TCP stream, I can follow HTTP stream, but yeah, as you can see here, this is just Firefox data. You can go up to stream, click no Firefox, nothing to do with Tufts.io. And then you can do a file export object. You can dump the HTTP stuff, but it's all certificate stuff that Firefox uses. Now this is no good. So now you can see the big difference on what it's like when you visit an HTTP website versus an HTTPS website. Like HTTPS website, you can't reconstruct the website at all. Now what happens if you're on a VPN, if you're trying to browse Tufts.io on a VPN? Well, then guess what? You can't make anything out of it, anything. Virtual private network, if you enable that on your computer, all the traffic, anything that your computer does gets encrypted. You can't make anything out of this. But the moral of the story is this. Always use secure and encrypted services like HTTPS or SSH or FTP. Which now leads to exercise number 2, extracting pictures. So we're going to do this exercise now. Open up set2.pcap in Wireshark. And what insecure protocol was used to transmit pictures on the network? How many pictures were transmitted? Extract one of the pictures that was transmitted. You can show and save the picture as raw format. Here we go. All right, so I'm going to go to set2.pcap. Well, here we go. Set2.pcap. Should be a small pcap file. Okay, I don't need this anymore. And dump that in the trash. But now I'm going to open up set2.pcap, which is 391 kilobytes. There it is. How many packets are here? Well, it's no longer 8, it's a little more involved. 482 packets, because there's 482 rows on the table. You can see, actually we're using a different IP address. There's only 2 IP addresses in this set2.pcap. 192.168.1.228 and 192.168.1.8. As you can see from the first packet, 192.168.1.228 at port 49979 sent a sync packet to IP address 192.168.1.8 at port 21. Port 21 is famous for the file transfer protocol. You can see the TCP three-way handshake happening in the first 3 packets. And of course the 4th packet, you can see the protocol changes to FTP. File transfer protocol is on layer 7 of the OSI model, and file transfer protocol is also, well, everything is insecure. Everything is done in plain text. File transfer protocol for years have been used for uploading and downloading software. Legal, illegal, doesn't matter. FTP servers still exist today, but they're going by the wayside because FTP is, well, everything is done in just, well, sent in plain text. So, now we know the insecure protocol that was used to transmit pictures, which is FTP. Now, how many pictures were transmitted? Well, let's right-click follow TCP stream. Ooh, juicy. Hey, you can see the FTP server, the username and password that I use. Username is Woodward, password is Babyshark. And you take a look. The first stream that you can see in Wireshark when you follow TCP stream is the transaction log from my computer to the FTP server. You can see the commands that were typed in and the files that got transmitted. I see a JPEG here, another JPEG, a TXT file, another JPEG, and another JPEG. You can even see the file names. Wait, I can see the JPEG file that was sent or the text file? You bet. This is where now you can click on the stream. It says here there's 6 total streams, starting at stream 0. So you can go up to stream 5. Can we see what the first picture that got transmitted is? Yep. There you go. Stream number 1. Ooh, a lot of garbage characters. I see very few human readable text except for a JFIF. I see Photoshop. I see Apple. Okay. Click another stream. There it is. Another JFIF. Hey, this looks like binary data of a picture. Mm-hmm. Binary pic. This is all the binary of a picture. Yep. Let's go to stream 3. Remember there was a text file that got sent? Well, here it is. Cybersecurity as real politics. Given on August 6th of 2014. This was Dan Gehr's keynote to the Black Hat conference that year. Black Hat 2014. Shit, 10 years ago. Over 10 years now. Now, because this is ASCII text and we can read it ASCII text, hey, guess what? I'm going to do a save as. Yes, I'm going to click the save as button here. I'm going to save this as, I'm going to say dan.txt. There it is. Watch this. I gotta send this to Dan. Cat dan.txt. Boom. Oh, I'm gonna clear the screen. More dan.txt. There you go. Pretty cool. Now clear the screen. We're gonna need this again. Got a Wireshark. Can I go to that window again? Damn it. That window was missing. The window. Ah, here it is. Another JFIF. Another JFIF. Alright. Cool. Can we save all like the pictures to the desktop and then we can render the pictures? And the answer is yes. Is there a functional difference between save as through follow TC versus doing it for the file menu? There isn't. The only difference is you're cheating. You have to learn the hard way first. I'm doing it the hard way. Actually, the functional difference is if you do a export from the file menu, it'll just dump everything. So, of course, the export method is much more efficient if you just want to dump everything. You don't want to, let's say, for example, there's like 50 pictures. You know, you don't want to do this 50 times doing the save as on the follow TCP stream. That's the functional difference. But I'm showing you the difficult way. All right. So I'm going to go back to stream number 1. Now, I can just do a save as here. I can click on the save as here and I say output 1, save as. But the problem is, the biggest problem is, it will just save the data as ASCII text, which is what we don't want. So I'll do it right now. Save as, output 1, save. And now watch what happens if I do a more output 1, because it was saved as ASCII text. This is ASCII text. It's not going to be a picture. So you got to be careful on how you actually save the contents of a file in Wireshark. You got to be very careful. So now instead of showing it as ASCII text, you want to go to raw. Now you do a save as output 1, and notice the difference. Output 1 already exists. Do you want to replace it? Yeah, replace it. Open up a terminal. Now if I go back up and say more output 1, and well, output 1 is a binary now. I'm going to say yes. Boom. I'll come back to this in a few minutes. Let's go to this one. This should be another picture, right? I just have to switch from raw to ASCII. Yep. Back to raw. Save as. Output 2. Stream number 3. This should be the text. Yep. We don't want that. We don't care about this. This picture. Go to raw. Save as. Output 3. Now you notice something very peculiar here. Why am I not putting a file extension? Why am I not doing output 4.jpg? Well, that's because we want to actually use, I want to show you what happened. I'm going to close this. What happens if you do a file output 1? Run the file command on output 1. That has no file extension. The file command will identify output 1 as a JPEG file. Output 2 is also a JPEG file. Output 3 is also a JPEG file. Output 4 is also a JPEG file. And the reason why I did this without the file extension is 2 reasons. Number 1, this is to show you the Linux, the command file. And number 2, this is why having file extensions is important. So I'm going to move output 1 to output 1.jpg, because now we've confirmed that output 1 and output 2, output 3, output 4 are all JPEGs. 3, 4. So the 4 pictures that got transmitted from on this FTP server: picture 1, picture 2, picture 3, and picture 4. Four pictures and 1 text file in set2.pcap. There you go. All right. Close this all out. Yeah. Command line tool. Again, I have to re-emphasize the importance why it is so important to know Linux, Unix commands. And we're continuing off from what we did last week. Again, required years of practice. We already used the file command today. If you install Wireshark, it will also have a command line based Wireshark called T-Shark installed. Yeah. So I'm going to do where is T-Shark? Yeah. Man T-Shark. Dump and analyze web traffic. So if I go to, well, if you go have a T-Shark, if you have a PCAP file, you can just do T-Shark -R. Yeah, I can do it. Do the documents, PCAPs, bootcamp. T-Shark -R set1.pcap. And there's Wireshark for you, but in command line form. Okay, but why is this important? Well, the reason why I have to show you T-Shark is because you can do things such as, you can do everything in T-Shark like what you do in graphical Wireshark. But one of the things I find really easy, if you just want to get like things like a list of all the host IP addresses and their corresponding domains and an IP and a PCAP file, you can just run this command: T-Shark, open up a file, -q -z host, IPv4, and you just get a list of all the IP addresses with their resolved with their resolved host. Can you open up a JPEG to a terminal? You can. Sure you can. Clear cat output 1.jpg. There you go. That's your JPEG file. Font Ranger. There you go. That's your JPEG file in terminal. Of course, if you want to actually open up the file and like so you can see it graphically, you can just do open. On Mac OS, you can do like open output 1.jpg. But yeah, pictures are binary. Oh shit, I just lost the, damn it, I just lost the, oh no, here it is. Just lost the damn presentation. Alright, nope, no I didn't. Alright, let's do one more. One more, actually 2 more. Reconstructing a media file. Open up set3.pcap. Now set3.pcap is a little bit more involved. Alright, set3.pcap. Set3.pcap is over 30 megabytes. And I'm gonna now go to here, close the filter, open up set3.pcap, 38.6. There it is, 38.6 megabytes. Two IP addresses, 192.168.1.228, and the destination at 192.168.1.20. We're using 7777 for this. You can see a TCP three-way handshake. But this one has 38,469 packets. That's a lot. 38,469 packets. Well, what got sent? Right click, follow TCP stream, and notice, Now before you do anything, notice that there are the counter for client packets near the bottom left corner of the TCP stream is still running. 22, 23, 24, 25, 26, 27, 28. Make sure it stops first. That's it. 31,582 client packets. So it looks like 192.168.1.228 sent 37 megabytes to 192.168.1.20 at port 7777. Now, oh shoot, now I have to redo the count. Alright, this is raw, so this is good. We're gonna jump the gun a little bit, and now when this stops, we'll do a save as to our desktop. I'm gonna save this to my desktop called media. Close this thing. And there's a media, here it is, media. Clear, ls, file, media. QuickTime Movie. Change that MOV. Even better, you're not gonna get rickrolled. Now I'm gonna open up the media file. Open up the media. Once upon a time I was falling in love. Now I'm only falling apart. Nothing I can do to get so hard. That was a real video, folks, and this was from Las Vegas, DEF CON in 2019, before those years. The piano bar at the Paris Hotel. Yeah, fun times. Yeah, from 2019. I kept playing that video in 2020, 2021 because I wasn't so sure if I was ever going to go back to Vegas and Paris. And my friend Peter and Josh, we hung out at the bar. And a lot of things have changed back since then. First of all, I don't drink anymore. Still see Josh, still see Peter all the time. But unfortunately, the piano bar at the Paris Hotel is no longer there. Well, thanks for the memories. No, the lab doesn't rickroll. No. Not yet. Not yet. Alright. Yeah, what kind of a media file it is. We did that as a movie. All I just used is a tool called Netcat, which we'll talk about next class, next Twitch stream on sending the media file. Now, we're going to do one more PCAP file, and the first thing is, before we do that, I want to talk about this thing called base64, which you really got to know for this class. First of all, base64 is an encoding scheme. What is an encoding scheme? It's used to represent or translate binary data into ASCII text format. Do you remember earlier I just spit out binary data onto the terminal? Actually, I still have it. It's if you do cat output 1 dot JPEG, this is look like, yeah, you see the wonkiness. It's like you see the dot. This is what happened when you spit out binary data to anywhere. Things look wonky and also sound wonky as well. Base 64 is not encryption, is not encryption, is not encryption. It merely just translates binary data into ASCII text because ASCII text is much more safer. But why is this important? Anyone ever done something called basic HTTP authentication? I'm going to show you a picture. You've seen this before. When you go to websites, you see this picture. Here it is. Base 64 auth. You see like yeah. Here's a good one. You get a little gray box typically that enters, or a white box on Firefox that enters your username and password. That's basic authentication. There's another picture. Basic authentication. Let me just do one here. Here it is. Like, you've seen this little box. If you see a box like this, or a box like this, or a box like this, when it says authentication required, that's basic authentication. But here's the thing. Why is this important? Why base 64 is important? Because one of the uses of base 64 is a request containing a header field of the form authorization : space basic space and then the credentials, where the credential is the base 64 encoding of the ID and the password joined by a colon. Hey, Anchor. Working hard? Is everything okay at work? One of my favorite tools, which we use all the time, is base. If you do a search for base 64, base64decode.org. This is free. Okay. So I'm going to give Anchor a message. Anchor, hold on. I'm going to write Anchor. And I hit, actually, this is decoding. So I want to encode. I'm going to encode the message, and I'm going to send Anchor a secret message. Again, as a joke. Hey, well, I'm going to keep my mouth shut. See, let's say Anchor received this message. Actually, I'm going to give you another one. I'm going to add another period in here, and yeah, this should be a double equal. There you go. Let's do that one or that one. Okay, doesn't matter which one. But the reason why I want to show a string, base 64 encoded string with equal equal is, anytime you see a string that ends with equal equal, it typically means, hey, the string is base 64 encoded. What does the double equal sign mean? Okay. Padding. There it is. Here it is. Why does base 64 string has an equal sign at the end of it? Padding. One of the outcomes of this class is called recognition. So recognition, intuition are very important. If you see a string that ends in double equal or equal, it typically means padding, or base 64 string. Now I'm going to take this string with a double equal sign, hit decode, paste, and okay, here's the encoded string, try to decode it. There you go. Anchor, that's the secret message. Unfortunately, too many people think that base 64 is used for encoding. Used for encryption. It's not. You may use it for secret message passing, but don't expect any security. Okay? So now I'm going to go to set4.pcap. No, set4.pcap. Ooh. Here it is. And we're going to look at set4.pcap. Base 64 is not encryption, okay. Okay, do we use it because people can put random characters in their password, or encoding it to base 64 make it illegible? Really is to prevent the misplaced spaces and all that stuff. Yeah. Unfortunately, base64 is also used to share messages back and forth. But yeah, but the reason is the misplaced characters and all that fun stuff. Like, get me out of here. Get me out of here. All right. Now, I just want to show you this slide again. HTTP basic authentication uses authorization space basic. So what we want to do in set4.pcap, here it is, extract username and password pairs. What protocol was used to transmit the username password pair? What is one username password pair in the thing? Is the username password pair valid? Why or why not? We're going to go over time a little bit. So how you do a search is this. The little magnifying glass. Packet details. Search for string. Authorization space basic. Now in wide and watch what happens. I'm going to hit the find now. I'm going to look for the string authorization . Ooh, we got one. Authorization space basic. So we found one in HTTP packet. I'm going to copy the value. Yeah, I'll post the slide soon. So here is one base64 string. We try to encode this, we try to decode this. Oh, I had to remove the basic. B. Rogers is the username. The password is they played with great character. Let's find another one. There it is. Copy the value ZG1. Uh-oh. There's another credential pair that we found. We're going to decode this. Oh, remove the basic. ZG, capital Z, capital G. DMOYES, Dave Moyes. D Moyes, I am a football genius is the password. So D Moyes is the username. Is there another one? Yep. Copy the value. Yeah, nostalgia. Some things never change. The YW91. Oh, this year's username and password pairs get really tricky. A. Ausler, username, password, and ID10T expert. Ooh. Is that it? Yep, that's it. What Wireshark does, it actually can decode, it does actually, believe it or not, Wireshark also decodes a base64 credential. You just have to expand it. Credential, B. Rogers, they played with great character. Find again. ZG. D. Moyes, I am a football genius. A. Ausler, ID10T expert. Yeah. Now, this is also one very important trick, especially for something that you got to know. You can actually now in Wireshark dump all the usernames and passwords that's sent in plain text very easily. Go to Tools, go to Credentials, and you can see all the usernames that are in the PCAP file, all the credentials in the PCAP file. It will show you the username. It doesn't show you the password. You can see the protocol that was used, HTTP basic auth, and also the packet number where it found the credential. So again, this is very important. To dump all the credentials in a PCAP file, go to Tools menu, go to Credentials, and that's it. However, you play Wall of Sheep, you just can't just dump these usernames and password on the Wall of Sheep. Really? You have to make sure that you verify the username and password credential if these are legitimate or not. So wait a minute. How do you actually check if a username password pair is legitimate or not? And here's the key. You cannot go to the website or domain, enter in your username password to determine if it's valid. Folks, that's illegal. That's Computer Fraud and Abuse Act material. That's unauthorized access. You don't do that. Fortunately, you just resort to what we know and what we've done for the whole day today. What we've done today. Just right click, follow. You can follow HTTP stream and you can see, oh, this is raw, but you're going to, nope, not CRAs. ASCII text and, oh no. 401 required. Okay. This server cannot verify that you have requested a document to be either you supplied the wrong credentials, bad path. No, that's not good. Hey, that credential, that B. Rogers one, that's not good. 401 authorization requires bad password. You follow the right click, if you follow the TCP stream, it doesn't give you a good message. What about the next one? The B. Rogers one. Oh, no, that one. The D. Moyes one. No, we're going to clear the filter. Go to the next one. This is the D. Moyes one. 138. Follow HTTP stream. Still got a 401. If this was a legitimate username and password entered, it would say something like 200 or OK. Something that is not an error message. This is not good. If you would say like login correct, OK, use your judgment, but it doesn't say any of that. It's not good. One more. We're over time today. ID 10T expert. Follow HTTP stream. Not good either. Doesn't say OK, it doesn't say 200, it still said bad password 401. So we have found 3 password pairs in set4.pcap. We have found, in set4.pcap we found 3 credentials. None of them were valid because they were all 401 in the response. If you take a look at the HTTP stream. So this is not good. Nothing's going into the wall of sheep. And that's all for today. So where do you go from here? So you can sniff and validate password. Yes, you can now go ahead and record network traffic. Wall of Sheep is always looking for volunteers. We have many, you can hone your skills at the Packet Inspector event, develop your skills at Packet Detective. We even have a DEF CON Black Badge event called Capture the Packet, which will give you a black badge, will give you lifetime admissions to DEF CON worth, that's like a $10,000 prize. And folks, we are way over time today. And next week, we'll talk about network reconnaissance. But now I'm going to post this video and the slide to everyone. Thanks, folks.